This video is going to cover removing elements from an array. It's going to use a lot of the same things we used in accessing and assigning elements to an array. So we're going to start off with array A, which is going to be the same one we had before. It's 2, 5, 7, 45, 99, 77, 1, 3, and 42. And then we're going to start off, we're going to try to remove a single element. Now, here's the rule when you're dealing with removing things, and just arrays in general. You have to maintain this rectangular or square consistency in the array. In other words, I cannot remove one element and have an array that has a hole right there. I can't remove one element and have an array that has a hole anywhere. I can't create a hole in the middle, right? All rows have to have the same number of columns, and all columns have to have the same number of rows. I think that's probably the best rule. Let's put that down. All rows must have same number of columns, and all columns must have same number of rows. Okay, so if I were trying to remove this 7, then row 1 would only have 2 items in it, whereas rows 2 and 3 would have 3 in it, and you can't do that. That's a violation. If I were trying to remove this in the middle, which would then squeeze this down, now row 3 would only have 2 items in it, 2 columns, whereas rows 1 and 2 would have 3 items. Likewise, row 3 would only have 2 items in it, or excuse me, column 3 would only have 2 items in it, and columns 1 and 2 would have 3. So that would violate this rule. So if you keep this rule in mind, then it sort of governs what you can do, what you can and cannot do when removing elements from an array. So let's look at this. If I did something like A13 equals empty vector, same as when we did vectors, you assign the empty vector, but this is assigning the empty vector to 1 comma 3, which basically that's saying get rid of the 7. That violates the rule, so that's going to generate an error. And so we'll see that here, and we get an error, and it tells us our dimensions are basically mismatched. So we can't do that. So that's the number one mistake. So don't do that one. So let's go down here to the next line. Now what we can do is we can deal with whole rows and whole columns and multiple rows and multiple columns, because if I remove the whole row, let's just take, for example, I take out the first row. Now my rule is still maintained. I got rid of one row, so each row has the same number of columns and each column has the same number of rows. So we can do things in that fashion. So let me put this one back, and let's do some code here. Erase that one because that gives us an error. And let's say A1 comma colon equals the empty vector. Now what I've done is I've said the first row, all columns equal the empty vector. So basically the first row, all columns are going to get assigned the empty vector, and they're going to go away. So when I run this, you see I'm left with the vector the array 45, 99, 77, 1, 3, and 42. This also works on multiple rows at a time. And so if I were to come in here, put that back, and I'm going to come in here and say 1 colon 2 colon 3 comma colon equals the empty vector. That means that's the same as the vector 1, 3. So row 1 is going to get the empty vector. Row 1, all columns, gets the empty vector. So that goes away. And row 3, all columns, gets the empty vector. That goes away. And so you're left with, when you execute this one, you're left with the row 40, 45, 99, 77. Okay? Keeping on with our example here. You can do the same thing with columns, of course. So if I come in and do A colon comma 2 equals the empty vector, as we'll see over here in MATLAB, the second column, all rows in the second column will disappear, and that will leave us 245, 1, 777, 42, as seen there. We can also do multiple rows, multiple columns. And so this particular line of code, line 13, we're going to do all rows, columns 1 and 3, which is only going to leave the middle column, column 2, which is 5, 99, and 3. So there you go. Now, you cannot do, the last example here is going to be, it's going to throw an error. It's going to throw an error because it violates our main rule. So let's look at this one. If I get A 1:3, comma 1:2:3. So basically, rows 1 and 3, columns 1 and 3, because this just equals this vector here. If I do that, equal to the empty vector, what it's going to try to do is put the empty vector in these locations. Remember from before, 1, 1, 1, 3, and then row, oops, that's wrong, not 1, there you go, I'm sorry, let's do that, there we go. So it's going to try to put it in 1, 1, 1, 3, 3, 1, and 3, 3. Now when we were adding stuff or changing elements, we were able to place these at the corners because that still maintained this integrity here. All rows had the same number of columns, all columns had the same number of rows. But if you try to put an empty vector into all 4 of these, which is what this line is essentially trying to do, basically you'd be erasing the 4 corners. Now, not all rows have the same number of columns, and not all columns have the same number of rows. So that's why line 14 throws an error.